This assessment asks us to predict the product of a reaction between the amine and the anhydride shown on screen. Now, in terms of carboxylic acid derivatives, anhydrides are somewhat reactive, right just below acid chlorides, and amines are relatively strong nucleophiles given that nitrogen is less electronegative and therefore very willing to share its pair of electrons. Given that, this reaction is going to go by mechanism 18A, where the nitrogen uses its lone pair and attacks the carbonyl directly. Note that it's going to bring along its proton so that we end up with the product shown here. So we'll draw in the two protons on the nitrogen. Because both came along, we end up with this as our tetrahedral intermediate. And I've abbreviated the phenyl groups as pH to make this easier. At this point, we've formed our tetrahedral intermediate. The tetrahedral intermediate is going to collapse. A lone pair of electrons will kick back down and kick out the carboxylate leaving group. That's going to give us this intermediate here, where now we still have the positive charge on nitrogen. And we can think of this at this point as a protonated amide, where the nitrogen has been protonated. The other thing that we formed here is the carboxylate leaving group that was part of the original anhydride. All that remains is for triethylamine, our base that's in solution, to remove the proton from the nitrogen. That's going to complete formation of the amide product. The product of this reaction between an amine and an anhydride is this molecule here, this amide.